Hey, what's going on, folks? It's Mike here, and welcome back to the Modern C++ series. In today's lesson, I've got a fun one for you. We're going to be talking about formatting text with the std format library, and it's a real neat addition to the C++20 library, so I'm really excited to introduce this to you. So let's go ahead and begin here. So there's a lot of different ways where we could print out formatted text. For instance, if I go ahead here into our C++ code here, let's just go with the classic here. We can use standard printf, for instance, and I can write out some value here. Let's give ourselves an integer, I or something, and assign it a value because that's a good idea to do in C++. And sometimes we do this with the curly braces here. And let's just say integer is, and I put some format specifier %d, and the integer. And let's go ahead and try to compile this. But again, what library we're going to need to get the C-based libraries here? Let's see here. Well, let's go ahead and just get it compiled first. Let's make sure we're using C++20. And compiling our program, and I guess it is included there somewhere, but we do print this out here. So we get integer is %d here, no problem at all here. Okay, so this is really neat that we could do this here. And let's go ahead and just clean up that example here, and I'm going to make sure I can compile and run in one line here. So integer is 72 here. Now, what if I do something wonky like put %f here as a format specifier? I get a warning, but then I get this weird like integer is 0.0. So it's a little bit problematic, okay? So we don't necessarily like doing stuff with printf in C++. And the advantages of what we're going to look at today, which is standard format in the utilities library here, is that we can get some type safety here. And std format, I'm also going to make the argument for, and why it might be a nice adjustment in your code, is it's a little bit cleaner than us doing this type of thing here. Standard cout. Integer is, make sure I put a space here in the right place, integer, and then I'll go ahead and do the end line here, and that will compile properly. So we don't have the type issue, so that's one reason why we like these streams better. But we're going to find out that format is, we get the best of worlds of how we format our text here, and we get sort of the type safety or the right thing that is printed out here. And we're also going to find out there are some advantages of std format as well. And from some benchmarks that I've seen, folks have even claimed, and what I've seen from some results is format's actually a little bit faster too, because it's generating the right string for us. Okay, so anyways, let's go ahead and take a look at format and what this is all about here. So I'm going to go ahead and open this page. Let's go ahead and zoom in the window a little bit here. And the std format or standard format library here is a text formatting library that offers safe and extensible alternative to the printf family of functions, is intended to complement the existing C++ IOStream library. So we're going to still use this with things like cout, for instance. You can use this with things like iterators and so on to build strings. We'll go ahead and get a basic look at it today. But overall, these are our functions that we're going to need here. So we're going to need format. We have format too, which also works similar to format, except you can use it through an output iterator or writing a buffer. Maybe we'll have a separate video on that because I just want to introduce format today. And that's the basic idea here. So again, a pretty mature library. It was based off of a library by Victor. I'm going to go ahead and click on this PR here if you want to go ahead and see the full published proposal here, which has some nice ideas with the motivation, and you can see some of the implementation details. So again, sometimes on the newer C++ features, again, as you're watching this series, I just want to teach you how to look at some of this stuff. It's useful to be able to look at some of the papers, and you can even look at the defect reports so you can see how the language incrementally changes and improves over time. So anyways, that's the idea. So getting a first look at this, let's just look at a hello world, and then we'll dive into some of the more interesting stuff here. And there is a few other things to talk about as we get started here. Okay, so this is like the old school C style way, which is not type safe. And this is the more verbose and somewhat, I'm just going to say more verbose right now. But I'll say, and potentially more expensive way of outputting text. That goes for both of these. Again, I've seen some reports that standard format is faster. I would have to benchmark those myself, as you would as well. But what we're going to do with the format is first and foremost include the format library here. So let's go ahead and include that. And let's go ahead and just kind of follow along this example here. Now looking at format here, let's go ahead and just open that up here. So that will be our first formatting function here, just a function here that we're working with. But you could see basically the form of this is it's going to return some sort of string. Okay, so we're just sort of working with our string library. And there's going to be some sort of substitution. So again, we're sort of thinking in the same printf style way here. Okay, and this value 42 is going to go within these curly braces. Okay, so let's go ahead and get ready to do that, and we'll take a closer look at format. But let's just go ahead and get something working here. And what I mean by working here is we'll start with format. Let's just do like and subscribe. You know, the classic sales pitch here. And we'll go ahead and put, you know, you can put your own name here, Mike here, something like that here. Okay, and then you still do the same stuff you would do, because again, this is just returning a string here. Okay, so let's go ahead and make sure that this is working. Let's compile it. First thing that happened here, fatal error, no such file or directory here. Okay, so the first thing that you need to check, since this is a relatively new feature, even though we are on C++ 20 here, go ahead and do a G++, check the version of your compiler. I'm on version 11.4, and if you go over on CPP reference here, let's just open up another tab here, and if you look at the compiler support for C++ 20 features, and we search for format here, for text formatting, we need at least version 13, okay? So if you want to install that, you can install it from source. You can see how I do it on my video, or you can just use your package manager. However, you can get a GCC or G++ rather 13 version is all you need there. Okay, so I've already set that up here. So just make sure that you're using G++ 13. And of course, if I'm specifying it right, you should get at least version 13 here. Okay, so that's the first fix that we're going to need to make here. Should be first and only actually. If it compiles, we still get our warnings from earlier, so let's kind of comment those out here, just so we're focused on one thing at a time here. But we should see like and subscribe to me here, okay? And as you can see here, Mike is just being put in within the curly braces here. Okay, so left and right curly braces, that is sort of your placeholder. And that's actually kind of the elegance of this text formatting, that we're going to actually say how we want the text to be formatted by placing in different specifiers here, okay? Now, a few things to keep in mind here. If you want actual curly braces in your thing, you can escape them by using two curly braces here. Okay, so that'll actually give you curly braces. You'll notice it didn't do the substitution here though, because again, that's just escaping the curly braces. So let's just go ahead and say maybe you want Mike within the curly braces. And again, I'm just going to put in the curly braces again. Okay, so this is where the substitution is happening, and then the double curly braces, kind of like the backslash that you might be used to for like the end line and stuff. That's what's escaping here. So it looks a little bit wild, but you know, syntactically, you know, that works here, and it's not too bad here overall. Okay, so there we go. There we get Mike here. All right, so let's go ahead and take a look at the actual std format text formatting function here and see what that looks like. So overall, it is a templated function here. Again, so we're doing things at compile time. And really the advantage of that is it allows us to do checks at compile time to make sure that we're not generating some illegal format string. Okay, so for the instance where we were mixing in our code here in the C style, this float for the integer, you know, C lets us do that, but it issued a warning, you know, which is good, but you kind of want to know that this is a mistake here, right? If there's a type mismatch. Okay, so that's why this is templated here, so we can do some checks there. And this is using variadic templates here, so I can basically put in my format string any number of args here. And then for my arguments here, just look at the string version. This is, again, the variadic form of this, so I can put any number of items here. Okay, so let's just go ahead and play around with this here, okay? So again, the formal definition, format args. Okay, so that's going to be our sort of format string according to the format string FMT, which is going to be this part here, and return the results as a string. Okay, and then if present, we can do stuff with like locale and stuff, which is super useful. But again, let's go ahead and just kind of work on things one at a time here. Now another kind of neat thing that I want to go ahead and show you here that you can do with format, and then we'll just play around with some examples. Let's go ahead and just create our integer. Let's actually do something like month. Let's see, I'm recording this on June, so I'll do 6. Year, this is 2024 still, flying by. If you're watching this in the future, let me know. But let's go ahead and do the std format string. And I'll say it is now. And let's go ahead and do our format string dash, because I want to use 2 of these here. And I'm going to do month and year, something like that here. Okay. And let's go ahead and give that a try, make sure it's building. And it is now, 6/24 here. Okay. So what's kind of neat here, what I can do with format is this is in the 0th position, the 0th argument, right, in the template parameters. This is in the first position. So I can actually put a positional value here, 0 and 1, and that's kind of neat. And, well, I'll get the same result here. But let's see what happens if I flip these here, okay? I'm going to make this one 1, and this value 0. And we see that they're flipped. Okay, so depending on your region in the world, however they have dates, you could just do this simple flip. And this is what the locale and some of these libraries help assist with these types of things. But it's kind of cool that you could do this flip in just the format, but you don't have to mess with your code here. So again, that's kind of a nice thing I like, right? Where again, with the printf style, you have to move stuff around. With this style, you have to move stuff around. In general, I would recommend putting stuff in order anyways, but it's an easy flip, or you could imagine having, different ways to generate this type of code if you wanted for, whatever the right version is, okay? So that's one kind of nice thing here with format. So we have the positional arguments using numbers. So that's kind of nice here. Okay, so let's go ahead and dive in a little bit more into format, see what's going on here. All right. Okay, so here's a few of the equivalent forms here. Maybe we'll look at some of these in another video here. And then let's see. Since this latest PR, so again, you can dig into these and kind of see what the different changes are by Victor and the committee. Format does a compile time check on the format string. So there's a helper function. And if it's found to be invalid for the types of the arguments to be formatted, a compilation error will be emitted. So that's pretty cool. So I'm going to show you how to do the different format strings in a moment here. But we do want compile time errors for these things, right? It's cool that it's a compile time check as well. Okay, so again, that's just like a nice, thing versus, you probably don't want to throw a exception or something anyways, but you probably don't want this to be a warning, right? You want to do the right thing. So again, another advantage of format, when you wonder why does this thing exist, it's to help us write better code, better, safer, and again, as I mentioned, faster code, okay? Okay, so the format here, again, is the sort of object that represents the format string. So I can do, kind of interesting or wonky things too with this format string, like, for instance, let me just kind of widen your imagination a little bit here. And maybe I want to reuse these things here. So let's just kind of create a string. Now string is included into format here. I'm just going to include it for completeness. And in case there's any like string functions or something that might not happen to be included. I think the whole library is included anyways. But let's just call this my format. And it's just going to take this here. Let's just copy this. Format string, there, I got it. And let's just put it back here. And I just put in my format. Okay. And let's go ahead and give this a run. Let's see what it did. It says, the value of my format is not usable in a constant expression. Okay. So let's just read the message here. Few things here. Remember what we said about passing in things to format. We want to do a compile time check. So it says, error, the value of my format is not usable in a constant expression. Okay, what does that mean? Well, if I want to be able to put this in a constant expression, I need to make it const exper. Okay, so that's the first part here. Let's just go ahead and try this. Const exper. Okay, some sort of string here. And we'll figure out how to play around with this a little bit. Now we're getting another error here. It's saying, well, it's not a constant expression because string's going to allocate, right? And it needs to call new. Okay, so what tool do we have to make something, constant? We could do something like this, have a character pointer. Okay. Now if you caught it there, this worked, but we get this, okay, ISO C++ error. What's going on here? We need to make this const here, okay, so that we have some guarantee that this is our string here, okay? So there we go. Now it's working, and again, I copy and pasted the one with the escaped curly braces, so just a little thing to watch out for there. And then now we'll see we have my format string here, and I can kind of reuse this format here, okay, that I just capture, and I could pass that along here. So that's kind of a nice thing that I could do here with my format strings. I don't know, let's do like and subscribe to you, right? So then you could clearly see how we have this format string. Again, you could just have your formatters, maybe, just the curly braces and everything there, and you can pass those along. So kind of another nice reason here is the reusability of format string text for how to call this text formatting strings. I'll just call it that. That's the basic idea there. Okay, so some cool things that we could do beyond the positional stuff's cool. This is neat. Now let's start getting into some of the type safety stuff here. And with that's the actual let's print out some characters here. Okay, so let's go to our help here, and let's look at a few of these different things here. Let's see, format specification defined by standard formatter. Okay, this is our formatter spec. Somehow we got to get into this here. What is all this stuff? Okay, we got tons and tons of formatters maybe set up for different types of objects here. I'm going to ignore that for now. We just want to get to the spec here. This guy here. For basic types and standard string types, the format specification is interpreted as standard format spec here. Okay, let's go ahead and open that up here. And this is going to be the line we're going to pay attention to in a moment. Let's see what else we got here. Now, there's interesting other stuff that you could do with, we got the range format specification as well here. Let's just start with basic types, and then if folks are interested, maybe we'll have a separate video doing more of a deep dive here. But again, the end goal of standard format is a string object holding the formatted result. Okay, and it's something that we can evaluate on compile time. Okay. Now this is kind of interesting here. It's not an error to provide more arguments than the format string requires, right? This is just going to do two things, but if you have three, that's okay. That might be something you wanted to check or keep an eye out for, maybe in a linter or something, but it still works, which is kind of nice here. Okay. All right. And basically what we've got here, let's run this example just to see what the code is and kind of parse it here. We've got our main here. We've got our format, hello world. That's our hello world example. And then we're just sort of building up this format string here. Let's see. So we've got this is going to run 0, 1, 2, so 3 times. We're going to add in format here, and then we are going to call this dynamic print function, which is going to take in the format string. And again, it's just a string. Now we're being efficient and passing in a string view in this code. Alpha Z 3.14, and then an unused argument, right? And every time that this is going to run, it's going to add in, because you don't have to match everything, alpha Z, and then alpha Z 3.14. Okay, so that's kind of a neat example here. But really what this is showing is, as long as you can build up your string, which we're just appending a new sort of placeholder here, where we could provide a format specifier for how we want to specify this, which I'm going to show you next. That's kind of neat here. Okay, that's getting into the same idea like what I did here, where you're just building up some format string and then going to pass it in here. Okay. Now the trick is they're using this, let's see, v format, which we haven't talked about. But anyways, maybe we'll get into that later here. But I want to go ahead and show you the format specification here. This is kind of the line you have to pay attention to. That tells you all the different things that you can do for how you want to actually output something. So again, if you have a number and want it to be hexadecimal or print out an octal or binary, right? We're probably paying attention to this type thing here. Or if you want the sign of the number to be printed out, whether it's positive, negative, or not displayed, you do that there. Okay, so let's go ahead and take a look at this. And then we've also got other things like filling and alignment here. Okay, so let's just play around with a few of these examples so you get the feel for it. And we'll kind of do this alongside our example here. So let's just create an integer a. I'm going to make it equal to 10 because I know what that looks like. Actually, let's make it equal to 8 because I know exactly what that looks like in binary. It's a little bit of output here. And for our format string here, maybe let's use auto. We haven't used auto yet. So let's do a format here. And what we're going to do here, let's see. If I do :6, okay, and then let's just pass in a here because that's the thing that we want to format. And let's actually print these out here. String 0 and do an end line here. Okay, so let's go ahead and see what we get here. Let me make sure I add the extra quotation. There we go. What do we get here? Well, I get a 8 here. Okay. Now observe colon. What did that do here? Well, let's put another one side by side here. Let's do 5. See if you can catch on what the sort of pattern is here. Oops. And of course I've got to, let's increment these appropriately here. And this is how you kind of learn this stuff, just by playing around with it a little bit. But that looks like 1, 2, 3, 4, and that's in the 5th position, and that's in the next position. Okay. So what I'm looking at, again, as I'm sort of parsing this string format specifier is just, again, I'm just going to go kind of left to right, adding things here. And you'll see how we just kind of build this up here. Okay. Let's see here. And I kind of think about, this was just how I was thinking about it. I was thinking about it like in a Vim style where I do colon for a command and then like do something or move, right, do a motion somewhere. But this is kind of the idea here. Now we can do some other interesting things here. Let's go ahead and take a look at this one where I can actually fill that empty space here. So those 6 characters, I could put a fill there. By default, it is a space. So let's just do a bunch of these here. Let's go ahead and kind of copy. Let's just put a star here. And let's increment that to S2. Oops. S2. And I'm going to do one more here. S2. Let's see what we get. Oops, what did I do here? Okay. And again, the messages are going to come out a little bit scary. So this is good. We want to take a look at them. And they're usually kind of come out with like a failed to parse spec if you mess up the format string like I did here. And I'll try to help you, understand it as I understand it here. Usually, yeah, we'll get a pretty decent error here, right, in this constant expert expression. So again, these are templated functions, so we're going to be getting a bunch of template errors for these, for better or for worse. But they're not too bad. You're just going to see like a failed to parse spec type of deal here. Okay, so that means I just messed up the specification of my format string. And what are these doing? The less than or greater than symbol or this up symbol here. These are actually going to help control the alignment. So am I pushing to the left? Am I right aligning it? Or am I centering it? Okay, which is what the caret is here. Okay, so let's go ahead and put that in position here. Let's go ahead and do something like this. I think this is going to push it to the left. Yep, with all the asterisks as my fillers here. Okay, so if I've got space here, I'm going to put it in the rest of the characters. Let's go ahead and do it in the opposite direction, just so you can see the change. Let's replace it there and do string number 3. And we'll go ahead and do this one here. And instead of stars here, let's do underscores. Or how about, yeah, underscores work. Let's do that here. Let's give you something different to look at so you can see the difference between the right align. So this arrow, you can think of it like pushing in the direction to the right. this one pushing in the direction of the left, and then filling the space with asterisks. And if you're like me, if you write a lot of like command line utilities, this is the one I always like to do. I like to have like equal signs on either side of my headings. And let's go ahead and do that one here. So that'll kind of center our text, which is kind of nice here. Okay, so there we go. So that's what the caret's doing there. Okay, and it's going to put it on each side there. So that's kind of nice. So that is the fill and align here. Now let's say here we want to use sign here, because again we're just going to use integer and floating point types today. And how do I start to parse this thing here? Okay, what do I do for my sign here? So if I'm just sort of reading this, let's do one of these here. What if I put a well, let's see here. Let's look at the sign here. Sign indicates one of the following. So we need plus, minus, and plus indicates that a sign should be used for both non-negative and negative numbers. The plus sign is inserted. Let me make that bigger. Before the output value for negative values. Minus indicates that a sign should be used for negative numbers only. That's the default behavior. A space indicates that a leading space should be used for non-negative numbers, and a minus sign for negative numbers. So we have a few different options here. Let's again try to understand the formatting here. Here's our one value that we have here. What's the 0 doing here? 0, 0, 0. Do we remember one of our first examples here? Right. So another kind of neat thing here. Remember this where we did the positional arguments? Let's just start building that string up here. Okay. So let's go ahead down here. We're gonna do a bunch of these. Let's do string 5, and what we're gonna do here before the colon 0. And let's see here. I did put in the plus here. Did that compile? Let's see what happened here. No, yeah, we got the mess up here. So let's do this right. Clean this up here. Let's get rid of our plus. And I'm just gonna copy this example here. Let's just have a default. And we can put in the positional argument, and then we'll have another one here. Okay. So if I go ahead and print out number 5 here, let's see what happens. So again, showing you off another feature here. Let's save that, rebuild and compile. So again, what this is doing here is just another feature of text formatting. I could reuse this guy here. Okay, so if it makes sense to have it like displayed in 2 different styles or something, you could do that, right? Why would you want to do that? Maybe you're building a debugger or something, and you want to print out the actual value and the address of something. Okay, so let's put an example here. Can print out twice using the positional formatting technique here. Okay, but let's actually get to solving how do I get the little plus sign here for the sign. Well, again, if I look at this thing here, let's see, fill and align, that's the optional first thing, and then I've got the sign after. It didn't work before, but what if I put it, I could put it, what if I put it here in front? Okay, is that where it's supposed to go? No, okay, because again, these things are, I'm talking where to do the alignment here. Let's put it in front of the 6 here. Okay, let's try that version. And that works here, right? We get a plus sign here. Okay. So it's a little bit weird. Let's go ahead and put a, what if I make this -8 here, just to see, like, does it do something different? Then I get my -8s, right? That's the default. And again, let's undo that again, just a +8. Let me just rebuild this again. Again, you'll see the default version, but yeah, this version is using the plus here. Okay. So that seems to be doing the trick here for our plus sign here. Okay, so our sign. Y goes in front of the 6 spacing thing with the fill and align. Just a little bit tricky, I guess, here. So again, if I put the negative here, right, this just to show you, this isn't just like popping in a plus sign or something and saying, like, do the plus or minus thing. Well, that's pretty reasonable behavior here. Let's look at a few of these other things here. So what else do we got here? We got the optional pound symbol here. Let's see here. Oh yes, let's look at width and precision here. So what we've got here is F for floating point numbers, and we could do like, well, what's 0.5 do? Okay, that's the precision. So how many after the decimal? 1, 2, 3, 4, 5. The width here of 10, right? So this is pretty similar, right? As before, you do like 10.5 or something. Let's go ahead and try that out with some floating point numbers. Let's go ahead and do this here. And we're going to want to use a float F here. 3.142. 3.141526, something like that for Pi Day. Okay, let's see here. I should have looked up the digits of pi, but that's okay. And yeah, let's just do the default here so you can see what's printed out. And then again, I'll use the positional argument because we want to print this out 2 times. And, 10.5f. Okay, let's see what that does here. I run this. Oops, I got to use... let's see, S6 was not declared here. Oh, I probably messed up something. Auto error expected. Classic semicolon. All right, and there we go here. Let's see, so I got 5 digits, 1, 2, 3, 4, 5. And I have 6 digits that are about correct of pi, I guess, for whatever my brain can remember. Something like that. But anyways, you see the point here that it's giving the precision here and the width here. Okay, so that's something that we commonly might want to do here. Again, if you're building some scientific application or again in spreadsheets, right, you want to be able to see the precision and so on. Again, these are things that we could do with the regular output streams, but are nice to see as well here. And again, I like that I can output both of them in the same line here, so you could see like a maximally precise number or something, and just kind of play around with that. Okay. Let's see here. The last thing that I want to show you, because we're going to need this because we're going to talk about bit sets and so on, is the actual type specifiers here. Okay. So let's return. So this is going to be precision and width of the result. And let's go ahead and do another one here. Let's go ahead and create binary here. 7 is a good one. And auto. And we'll do this actually in a few different ways here. But again, let's go ahead and just see the default output here. And then let's go ahead and see if I put a type like B here. Okay, simple as that. And the quotations, put the binary here. And let's go ahead and write that out. This is going to be string number 7 or so. And we see 1111 here, okay, which is giving us our 7 here, okay. Let's do it a few different ways here. Let's do it with a capital B, because that's also an option here. Okay, so let's make this number 8. And number 8 here. Let's see if there's any difference that we can observe here. Let's see. Oh, sorry. I'm going to duplicate this. But you'll observe that, yeah, no difference here between these. So what's the difference here? B gives us the binary format. The base prefix is 0B. B same as, but the base prefix is just capital 0B here. Okay. Okay. Now, let me actually revisit this for a second. Maybe we're not quite happy with this output here because, you're usually used to seeing these in like sets of 4 or 8 or something like that. So what could we do with this format string? Well, remember what we learned earlier about adding padding in here and so on. So we could still use this and with a filler, put in, zeros or whatever here. So let's go ahead and do that. How do we do that? Well, we figure out the alignment, how much, and the character here. Okay, so let's make sure we get the order right here. 0, align, and then 4. Let's see if I did that right. Yep, there we go here. And let's go ahead and do that again. Let's use 8 this time here. So we can fill this in with zeros, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I can kind of parse those as a set of 4 and a set of 4 here. So again, that's kind of nice for our binary output. And that's useful, again, if you're doing like bit manipulation tricks or whatever. And again, with your format, you can do this in a bunch of different ways here. So let's go ahead and change it up here. Let's try out one of these here with the hex format. Let's use X here for that. Let's do this. And let's just print it out here. Let's see what we get here by doing that little trick. Let's see, 7 in hexadecimal should just be 0 with a bunch of, 7s here. Okay, so that's kind of cool. Again, I think about these things in GDB, whenever I fire that up, as I sometimes do here on my course, for seeing the different representations of numbers. Speaking of which, the last thing that we'll do here, let's go ahead and do a, let's kind of combine a few of these ideas here. What I'm going to go ahead and do is steal this line. And what I want to do here is just print out the, let's print out the pointer value here. Okay, let's do something like that here. So what if I want the address of something here? Well, it should be the same thing as C, if I recall here. There should be a P, I think, here. Yeah, that's what we want here. To give us the address. Okay, so I got to think about this a little bit here. But what I want here is the value, and then I want a format specifier here, and then I want the address. Okay, and that's going to be some string here. The 0th, well, now let's just leave that empty for now. But we do want P there. Okay, colon P here. Okay, and we'll set up our format string here. Or sorry, our string that we want to print out. But let's see, my format, let's call this like format address or something. And let's use standard format, which returns us a string. That's all it is. Format address. And then the thing that we want to, or the things that we want to pass in here. So I want the binary number. And in the second position, actually, I guess I could pass in the positional arguments here, 0 and 1 here, just to show this off. I want the address of this thing here, right? Address of binary. Yeah, let's just use this number here, right? So we should get the value of 7 here, and then the address of it, okay? Or at least that's what I think. But remember, this is a type safe thing, so I'm passing in the address. Okay, so that's maybe a pointer. Let's see what happens here. Yeah, I'm gonna get some sort of parsing error thingy here, okay? So we need to do sort of the classic C thing. And again, we could probably use a static cast here. In fact, maybe I'll try that after this works. But yeah, this is the idea here. We get our value, 7, and then we get the address of where this lives on the stack here, okay? Let's make sure that we're confident here. Again, you can always go back to your old tools as you're learning this. And we could print out the address of binary. Let's just make sure it's doing the right thing here. Okay, let's see here. This thing, yeah, looks equal to me. Okay, that's good. Let's make this just a little bit nicer. Let's do the static cast here. Okay, and put this in there. I think that's a little bit better, a little bit more modern C++ here. Let's see. There we go. Okay. So now we can find our casts when we grep. Now we want to learn the old stuff that we've been learning as you've been watching this series as well, as always. So anyways, I think that's the last one that I'll end on because, you know, that's the kind of useful like stuff I like to have, like these little format strings. You could write your little helper functions, then you could use these functions in your debugger or, you know, scatter these throughout your programs and your tests and so on, or your logging functions. And it really just makes it a much nicer experience having the format library here. So again, there's more stuff in the spec to dig through. I think we got a pretty good look at it here. I'll probably cover string streams, which are also useful. There are in my quick start in lesson 3 in particular for like parsing and stuff. But format, again, is really nice for, again, controlling getting your data in a formatted string, and then you can write it out however you want. So I think this was a nice addition for C++. 20, you need a more modern version of your compiler, so hopefully once you get one, or if you already have it, you can use this. I think it's a pretty useful addition. So anyways, just looking through this one last time here, because we covered a lot here with the format. Need to include the library here. It's more type safe than the C way of doing things. I think it's a little bit more convenient and more reusable than the output streams. It's doing stuff at compile time, so that's where you tend to, I think in these performance benchmarks, I've seen things get improved. As far as like, you're not constantly doing operations. You're just, here's the string at, compile time that you want to build or whatever. So that's kind of nice here. We get the positional arguments, which is super nice here. We can, here is an example of reusing. We've got different ways to align things and center things and put in little spacers, which is really nice. We've got the ability to print out signs. We've got the ability to do the width and precision types of things. We could print things out in binary or hexadecimal. We could print out the addresses. You can do all the different same things that you can do basically with cout and the different utilities there with the OStream libraries and so on. So anyways, folks, with that said, hope you enjoyed this. We're going to be using this a little bit as a tool in the bit manipulation just to practice a little bit, which is going to come up with some of our other algorithms. If there are any lessons that you've otherwise missed, make sure you check those out on courses.mshut.io. You can check those out and follow along in a distraction-free environment. And with that said, otherwise, folks, hopefully you enjoyed this. I've been waiting to do this video for a while because it is getting us into the modern C++ style of things. I think it's just a really useful tool to know, and hopefully we've demystified how to use it. It's actually a more fun thing to use. I know it gets a little bit complicated, even if I go back here just for 1 second, right? Like looking at these types of things here, but you can kind of parse them out and just play with them. They're really easy to play with over time here. And in some ways, if this is an argument against it, I mean, because it looks kind of weird, but again, you could parse it out, break these samples into small pieces of code, right? This is all you need to test and play around with something, So anyways, if you're interested in some other things, maybe since this video's already gotten quite long, we can take a look at custom objects or ranges or that types of things. Let me know in the comment below, and I'll be happy to continue the deep dive. So anyways, folks, with that said, thanks for your time and attention, and I'll look forward to seeing you in the next one.